Greetings, everyone. This is Irvin M. Howard, welcoming you to EMH Math Portal. I am Irvin Howard, serving as your EMH Math Portal online math tutor. Again, we'll continue the exponent series, and this time we're dealing with raising a product to a power. And I want to present the theory as well as the meaning of the formula illustrated on this sheet of paper here with my math EMH math logo. Raising a product to a power: if a and b are real numbers and m is an integer, then the product of two bases, which is a and b, raised to a power of m, which is the exponent that is an integer, then there's a sort of distribution to each of the bases. Notice in the formula, you're raising the power of m applied to two different bases. All right, and then your output, or it equals to a raised to the power m times a b raised to the power m. So you have the product of two bases raised with the same exponent. So in other words, to raise a product to a power, raise all factors within the parentheses to the power outside the parentheses as illustrated here. Let's do two examples. We have negative 4x cubed raised to the power of 2. According to the formula, we're going to raise the power to each of the bases, all right, to each of the bases. And notice we're going to have a combination of using various properties. So let's illustrate it in our formula writing. All right, so we have negative 4 raised to the power of 2, okay, times, which is the product of two bases, is still similar to multiplication, raised to the power of 3. All right, but you're going to distribute the power of 2 to the 3. And you remember about the power rule. When you raise the power of a power, it's the product of two exponents. All right, so this right here, all right, illustrates the power rule. You remember the power rule. All right, if you have a raised to the power of m raised to the power n, that equals to a raised to the power m times n. So right here, this is the power rule being applied. So you're going to have some, now you're beginning to see that there will be problems that will use various properties, different properties, okay? Now, this equals to negative 4, which is raised to the power of 2. So we're going to have two applications of two bases of negative 4. So since this is 2, so you're going to multiply negative 4 times itself twice. You're going to multiply negative 4 times itself based upon the exponent here. So that negative 4 times the negative 4 will give you a positive 16. All right, and then we have x times x raised to the power of 3 times 2. Remember, when you're multiplying exponents, you're multiplying the actual numbers. You're not, I've seen students do this quite a bit. They'll think that the 2 is the exponent with the 3, and this would be 9. But when you're using a power rule, you're multiplying the exponent. So this will be x to the 6. All right, and this is your answer. This is your final answer. All right. Okay, let's try another one, and then this is going to incorporate a combination of 3 properties, and we'll try to illustrate it on the paper with our formula writing. All right, negative, this is 3x raised to the power of negative 2 times y to the third, and everything is raised to the power of negative 3 outside, which is this exponent here. So what we're going to do as before, we're going to apply the raising up the power to each component. All right. So you're going to have 3 bases that will be raised to the power of -3. And let's perform that. So this is raising the power. So 3 raised to the power of -3. And then you have x raised to the power of -2. But you have -3 times this -2. So we're going to illustrate this right here just to show you what's happening. Right, because when you have exponents and exponents, when you're doing a form of distributing, you know that distributing also indicates multiplication in some way. So that kind of fit the power rule again. All right. So when you have 2 exponents, the products, you're going to multiply. And then we're going to have y to the cube. Again, we're going to have this type of multiplication, -3 of the exponents. All right, so this is based upon the power rule. All right, now this equals to, okay, -3 and 3. Let's keep it right here because automatically we know that when you have a negative exponent, what happens? We use the rule of negative exponents. All right, so we can go ahead and express that using the negative exponents. So we take this. All right, this is based upon a raised to the power of m equals to 1 over a raised to the power of m. All right, and this is the negative rule. All right, this is the negative rule. Right, and when we take, now since this right here represents the base of 3 raised to the power of 3, right, every time when you see whole number, it's like if you write the fractional representation, it would be 3 raised to the power of 3 over 1, because all numbers whole numbers kind of fit in the numerator. But with this formula, it switches them in the position so that if you have negative exponents in the numerator, they go to the denominator. If you have negative exponents in the denominator, then they go up to the numerator. And you'll see some examples later. And it renders it positive, okay? All right, and then we're going to continue with our formula writing. All right, so we have x minus x, a -2 times a -3, which is a positive 6. All right, and then we have y to the -3 raised to the power of, we have y to the 3rd raised to the power of -3, and this will give us y to the -9. All right, again, what we see here is that we see y is a -9, and this will apply to the power rule, the negative rule again. All right, because we just multiplied this to get negative. All right, so then let's go ahead and do the final process at the same time. So we have 1 over 3 to the 3rd, and then we have x to the 6th that stays at the bottom. Okay, and all of this is like multiplication. And then we apply the negative rule of exponents, and we have 1 over y to the positive 9. Okay, all right. Now you see here that we've inverted, or we've applied the formula, because the -3 up here from the previous one was in a numerator position. Okay, now all numbers that were in originally whole numbers are in numerator position when you write the representation of it as whatever the number over 1. That becomes that becomes invertible, so that it goes into the denominator when you have exponents. So again, when you have negative exponents in numerators, and when you apply the negative rule, those bases and exponents goes to the denominator. If you have negative exponents in the denominator, they will go to the numerator. And like so, when we simplify this, we have x to the 6th over 3 to the 3rd is 27, x to the 9th. All right, that doesn't look like x to the 9th. And let's draw it again, little 9. Okay, all right, that looks better. Okay, this was the demonstration of raising a product to a power, and I hope you enjoyed this math video. Again, this is Irvin M. Howard of EMH Math Portal, serving as your EMH Math tutor. I hope you enjoyed this video, and we'll prepare you for the next video, which will include solving exponential problems using the quotient rule of raising the power. Have a good day, and life is worth living.